So in this video we'll be talking about arrays, vectors and strings. So let's get started with arrays. So array is also a data type but stores the same number of values, same data type. So if I want to store my marks, so I can store this in array. I no need to create 5 or 6 variables for each subject. So let me declare this array. So we use the let keyword to declare an array, let L colon, and in this brackets we need to specify what type of data we are going to store. So by default it will be I32, so let's also store I32, and semicolon we need to specify how many number of elements we want to store, say 5 elements, and then here we need to normally declare these numbers 5 6 7 8 9. Now my array is ready. You can also change this to u8, so you can see these are below 255, so that means we can assign u8 as well. Now this is an array that stores all of my subject scores, so I can easily say my name, and if you refer to this array, that means these are my scores. So basically the L value will be pointing to the starting of the element. So L is an address, and at that address you will find the value 5. So let me show you how this value will be. So println, I'm going to print this in the debug format, and let's say L dot as underscore pointer. So we are getting the address of this L, so we can inspect this one. Let's go and run this one, and here we can see this is the address where this array lies. Now I'm going to show you how to debug this one. So you can see here we have already installed the extension code error db in the starting videos. Now you can see the red dot whenever I hover onto this line. So click on this line and make sure this red is highlighting. Now press F5. Now here you can see the L value. So these are stored like this, and here you can see 0 1 2 3 4, those are the indexes. So the indexes starts with 0, so this is the 0 index, first index, second, third and fourth indices. You cannot see the address here, but after I run this one you can see the address here. Now what we're going to do is we are going to read the first value from this address. So for that we use std pointer read function. So don't worry if these does not make sense, because in the future videos we'll be covering the unsafe functions, then everything makes sense. Just for demonstration of how we can read from the address, I'm showing this function. So this will take a parameter. So the parameter is the pointer L dot as pointer, and we need to convert this into the type of this u8. So as star constant u8. So that means whatever value at this address, treat it as a u8 value. So that is unsigned integer 8-bit. So we need to put unsafe because this is unsafe. Now the value will be, let's say, temp. Now let's go and print this value. Print the value temp. Now let's run this, and we can see the value is 5, and we can read the second value as well. So how you wanna do is we need to increment this pointer. So the address, if you add +1 to this, you will get the second index, because u8 takes only 1 byte. So, and we need to convert this into I size as I size, because this is the architecture specific, and we need to add +1 as I size. Now we will get the second element in the index. So let's go and run this, and now we can see the second element, that is the 6. And now we can increment this value as well, 2. Now we get the third element, that is 7. So this is how you increment. Suppose let's go and change this the data type to I32. So each number takes 4 bytes. Now we need to change this one as a 4 bytes. Now we will get the second element, because this 5 occupies 4 bytes. So if we increment 4 from the base address, we will get the second element. So let's run this, and we can see the value 6. Now you can also do like this to get the size of let's first say 4 into 2. So we will get the third index, that third value, that is 7. If I say 4 into 3, so I am moving 3 values from the base address. 3 into the size of each element, that is 4. 3 into 4, 12. So which gives me 8 value. Now you can also get the size of 4 using std mem size of, and you need to specify the I32 here. So if we run this, we will get the same value. So we can see the 8. Okay, this is how the array gets stored in the memory. So this is not very that important to us, but it will be very important. We are using WinAPI functions for malware development. Okay, so let's go and iterate over all these values. Also, the arrays are fixed size. You cannot add element and you cannot remove element. That's where vector comes in. And also one more thing, one more frustrating thing in Rust is you cannot declare a array of size dynamic value. So here I can see the L array the size is 5. So you can see I can change this to 6. I can change this to 7. But I want to create an array that takes command line argument. So my command line argument is program.exe. Now I want to give the number like 20. So I want to create an array that is of size 20. So I can change this one in command line argument to 25, and then I want to create array of 25. So in that case you cannot do that, because this value must be constant. So that's where vector comes in. So in other programming languages you can take the command line argument and you can create an array of that size, but in Rust all the sizes should be known at compile time. So let's go and iterate over this. For we can use for loop for I in 0 dot dot L dot length. So this gives us the range from 0 to the length of L. So now I can go and print the L of I. So this L of I is like accessing the index, accessing the element using index. So let's go and run this one, and you can see 5, 6, 7, 8, 9. But this is unsafe way of accessing indexes. So if I say -100, you can see we got some error. Also we can say 199, and you can see there are no errors, but there is no 199th element in this array. So let's run this, and we can see index out of bounds. So we can see the program has been terminated there. Now what we can do is we can say get of I. So this will gives us the option enum. So let res is equals to, so option contains two values, the sum and none. So if there is a value, it will be stored in the sum, and if there is none, it will be none. So now we are trying to get the element at this index. So let's say match res. So this is like a switch case in other programming languages. So the option contains two values, sum of value. So if there is so what this means is we are going to get the element at this index, say 0. So that is 5. So success. So that 5 value will be stored in this value. I'm going to print this value. Now if there is none, I need to just uh, move on. So I don't want to print anything. So let's go and run this. So this is the safest way to access the array elements. So now we can see 5 6 7 8 9. Even if I give 100, program won't terminate like that. So you can see the program still finished successfully without interrupting. So this is one way. This is the safest way to access the array elements. And another one is l.iter. So this will gives us the iterator, and you can see the previously the value is u size, that is the indexes 0 1 2 3 4, but now we will get the iterator for this one, iter. So iterator means a reference to these numbers. I can just simply print I. So let's go and run this one, and you can see the values. So iterator is like iterating over the items using a pointer. So this is like a temporary variable that is pointing to the address of 5 for the first time, and address of 6 7 8 9, and consecutively. Now we can also change these values. So let's say let mut is equals to, we need to specify this mute keyword to make this array mutable. So we can change the values of this array. Now we need to also change l iter underscore mute. So this will give the mutable reference. So we'll be talking about the references, ownership and borrowing in the next video. So now I can go and run this one. I get the same output. Now I can change this value using star I. So star is the dereference operator. That means you go to the address of that value and fetch that value. So now I'm going to star I plus 100. I'm going to add the value 100 to each of the element. So star I first goes to the address of this ampersand mute I32. So I have told you that I stores the reference to these numbers. So star I goes and fetches the value, and I'm going to add 100 to this one, and I'm storing it in the same location. So if I go and run this one, and you can see all of these values got incremented by 100. So this is one way of changing all of the values using the mutable iteration. So let's comment on this one, and you can also normally go and fetch the value without any changes. You can print this value as well. So let's run this, and you can see 5 6 7 8 9. Now there is another thing called into iter. Now you can see I change it to I32 value. So that means we are directly accessing 5 6 7 8 9 values. After this into iter function, you cannot access L after the loop, but in case of arrays we can access. In case of vectors we cannot access. So I can still access the array after this into iter. So it creates a consuming iterator. That means after the operation the particular array won't be useful. But this only applies to vectors because those are stored in heap, not on stack. So let's run this. So we can see all of these values. Also these arrays by default have the copy trait, so the copy feature. So by default this contains the copy, so you don't need to clone this in order to iterate, in order to use this into iter. So we'll be seeing that as well. And you can also check whether an element is in particular array or not using the contains function. So ampersand 8 So this gives a boolean value true or false whether the 8 value is in the array or not. So let's go and run this, and we can see the true. If I go and give the 100 value, we will get false. And we can also change all of these values using the map. So l dot iter dot map. So this map takes a value and returns after particular operation. So I want to add 200, and this will return a vector. We need to collect that vector. So collect of type vector I32. So don't worry, this example will be seeing same in the vectors topic. So let's say that t is equals to, and now if I go and print this one, I will get all of these values incremented by 200. So here we can see all of the values got incremented by 200. Okay, so this is all about the arrays. You cannot resize them, and that's where vectors comes in. So I had a diagram for you guys. So vector is a contains three parts. One is the address to the actual array, and the second element is length and capacity. So the address is pointing to actual contents. So here we may be 2 3 4 7 9 1. So this may be a vector. So the address will be pointing to the starting element, and the length defines how many elements belong to this vector, and capacity is total capacity the vector can store. So whenever we push an element onto this one, so we use the push function to add something at the end. So we can use push to push a value. So let's say 100. Whenever the push takes place, the capacity of the vector will be checked. If the capacity is only up to this one, so that means we need to allocate one more. So then the entire entire contents will be copied into another place, and then 100 will be added. So it's like totally rearranging entire array to increase the capacity. So that's why the vector operations are somewhat slow. So this length defines how many elements this vector belongs to. So let's go and see the vectors in action. So you can, let's say v1 is of type, and I also forgot that you can also store like this. Suppose I want to create a 100 array elements with zeros in it, so I can say 100 length, and I can also say 0 comma 100. So that means the 0, all of these 100 elements gets filled by 0. So this is the faster way to create the default values for all the elements. In the same way you can do this for vector also. So let's first see what is the vector declaration. So we can say vec keyword, and here we need to specify what kind of data type we want to store on this vector. So vectors also store the same data type as of arrays. but only difference is they can grow in size and they can shrink in size. So let's say I32 is equals to, and we can declare a vector in two types. First we can initialize the vector using vec macro, and then we can specify the elements 2, 3, 6, 8, 9. So you don't need to declare the size will be automatically captured in this value, in the length element of this vector. And we can also say v2 is equals to vector vec new, and here you can see there is an error. Consider so it is asking what type of elements you want to store. So I want to store vec I32. Now this is an empty vector. This vector contains elements. Now we can normally print these values as well. So run this and we can see all of these values, and I'm going to change these values to 65, 66, 67, 68, and let's say 69, and we can push the values onto the vector using the push. So we can push, let's say 100. Now let's go and run this one. Oh, we got an error. So mutable, I think. So cannot borrow v1 as mutable. So we need to specify mute keyword to push the elements onto that vector. So let's run this one, and here we can see the 100 element at the last, and we can also pop the elements from the vector. So let temp is equals to v1 dot pop dot unwrap. So we are directly getting the value of the last element. If I go and print this one, temp. Now let's run this, and you can see the first value is the 100, that is temp. Now let's put a breakpoint here, and let's see how this vector looks like. So let's go put the breakpoint and press F5, and now we can see the v1. So expand this one, v1 we can see there are 6 elements. v1 expand this one, and here you can see v1 of 0, 1, 2, 3, 4, 5, and also we have this raw value. So it is using some alloc vector of type I32 and allocate global. So if you can reconsider this in C#, we have this marshal.allocate global. So it is similar to that one, and here we can see the length and capacity. So the capacity is 10, so that means we can store up to 10 values, and if we try to store another value, then it will be reallocated and the capacity will be expanded, and current length is 6. And you can also see the pointer as well, so pointing to the 65 value, that is the first value. You can iterate through this vector similarly as we have iterated through the std pointer read function in the previous array method. So the capacity is 10 and length is 6. So this is how a vector looks like in memory. I just wanted to show you how this looks like. So let's stop this one, and now we are going to iterate over this vector. So we can do the same for I in v1 dot iter, and normally print the values. So you will get a reference to I32. If I go and dereference this one, I will get the values. So run this, and we can see the values. So we are pushing 100, so we are printing this one. So let's remove this one. Now I can also change this one, iter underscore mute. Now I will get the functionality to change the values. So star I plus is equals to 100. So I'm going to add 100 to each and every element. So run this and we can see 100 was added. Now I told you that into iter, right? So into iter. Now after this one I cannot use v1. So here we got an error, value borrowed here after move. So that means we cannot use v1 anymore. What we can do is we can clone this vector. So v1 dot clone dot into iter. So that means we are cloning into some temporary vector and we are iterating into that vector. So now I can run this one. So don't worry about this clone, we'll be using this in the next video and of the references. Now we can see we successfully ran the program. And we can also say iter dot sum. So this gives us the sum. So let's run this. So we can quickly get the sum of all elements of a vector. So this is the sum of all the elements of this vector. Now v1 dot iter dot map. So we are taking each and every element and we are adding some functionality. We are doing some operations and we are returning that value. So this is called function closure. We'll be talking about the closures in the next videos, upcoming videos. So these closures are anonymous functions, or like shortcut functions. You can quickly do some math operations and return them. So x into 2, and we need to collect this one. Collect into vector I32, and let's say t. Print all the elements in the t vector. So run this one and we can see all the elements have been multiplied by 2. Now another cool thing is you can generate the vector over the iterator of items. So I want to generate 100 numbers using the range. So let's say 0 dot 100. So 0 dot 100, and we can collect these values into a vector. So collect of type vector I32. Also let t1 is equals to, and print these values. So we get much more output here. All the values from 0 to 100. So okay, 0 to 99. This right one is exclusive. So this is a fantastic way to get a vector over an iterator. Now we can also have vectors inside a vector. So this is like kind of forming matrix. So let v3 is of type vector that stores vectors of type I32, and we need to say vec new. We got some error. Okay, remove this one. Okay, now we should good to go. we still getting error. Okay, we missed another one. Alright, so that should be good. So now this vector v3 can store vectors as a normal elements. So in this vector I have stored normal values, but in this vector I can store the vectors like this vector. So let me show you v3 dot push. Now here I can push the vector that can store i32 values. So if you find here, if you search here, we have v1 vector that can store i32 values. So I can obviously push these values, push this entire vector into v3. Okay, let's change this to mute. Now let's go and print this one, v3. So let's run this, and we can see this is the main vector v3 and this is the inside vector v1. And let's also say v2 dot push of 99. So let's copy paste this one. Now I'm going to push the v2 as well. So let's go and run this. Now we should see two vectors inside of this outer vector v3. So now we can see the outer vector v3 and inside vector v1 and v2. So this is the vector of normal values. We can also create vector of characters as well. So we can say t. So okay, this is the value we can store. Okay, we need to specify this macro. Now we are good to go. So in the same way you can push the values and we can pop the values as well. Now let's talk about the strings. So the strings are of two types actually interest. One is let's say let name is equals to laptop. Now here we can see the data type given by the extension rust analyzer is ampersand str. So this ampersand str is a string slice. So the laptop here is a string slice and it cannot be changed, and also this laptop string slice will be stored in the compiled binary itself. So it will not be generated on runtime. It will be stored in the binary itself. If you apply the strings command, you can see the exact string locating inside the binary, that is in the .exe. Now we can iterate over this as well. So let's using for I in name dot chars. So this gives us the each and every character of the string. Now let's go and print this one. Now we can see all of these characters. Now let's talk about strings type. So the string is also vector, but it stores the string sizes. We can also change these strings as well. So let my name is equals to my name of type string. So you can generate the string type from string slice using string from. Now you need to specify the string size. Here I want to generate the string from this name. So let's say name. Now I can print the my name. So you can see the my name is laptop. You can also generate like this, name dot to underscore string. This is also same as previous. So the laptop. So one cool thing about these strings are we can push and we can pop as well. My name dot push. So if you push, you need to push character. If you want to push a string slice, you need to say push string. So laptop is heating. So we need to declare this my name as mute and run this, and we can see laptop is heating. You can also pop the characters as well of this string. Now we need to, let's say we have a vector, so 65, 66, 67, 68, 69. So these are the let's copy this one. Let u is equals to vector of type u8. So these are the ASCII characters. You can convert these ASCII characters into the string. So we can do that using a string method called from utf-8 lossy, and we need to specify the array slice. So we can use u dot dot. So we are taking this okay, now we should go to, so we are taking a vector of this type and we are converting this into utf-8 string. So why we are using this lossy means it will put the question mark symbol whenever there is an invalid character. So let's run this. Now we can see we got the ABCDE uppercase. So let's go and put the 300. Now this is the invalid character of u8, but still if you want to convert this into this string, you will get the question mark in the string stating that this is the invalid utf-8 character. You can also convert a string into the utf-16 string, name dot encode utf-16. So these utf-16 strings are very helpful in the Windows API functions that are ending with w. So those required some utf strings, so there these functions gets useful. So this is all about the arrays, vectors and strings. If I have missed any functions or any methods, we'll be covering in the future videos.